Hello everyone, welcome to my YouTube channel MEP Learning. Today I am going to upload a video regarding HVAC design and drafting course. I have decided to upload videos related to complete HVAC design and drafting. Okay, so today it is going to be the first video, introduction to HVAC. I will be uploading complete videos in the coming days. Okay, means from basic to advanced level. Complete HVAC design and drafting course will be there. So now let's go. First of all, as I have created this course, considering that anyone who is watching may be a experienced person, maybe a fresher, or any like just BTech pass out. So I started this from the very scratch, means from the very basic. So first of all we will know what is MEP. HVAC is a part of MEP, like HVAC, firefighting, plumbing, electrical, all this is a part of MEP. And since this course is all about HVAC design and drafting, so we will continue with that also, but first we will know what is MEP. MEP means mechanical, electrical and plumbing. Okay, MEP refers to the installation of services which provide a comfortable space for the building occupants. Means MEP provides us a better living standards, or means living environment, whole MEP services. It makes our MEP is related to the services which makes our surrounding comfortable. Okay, it is a building service. It is related to building services, and in MEP various parts there, or MEP comprises of various parts like HVAC, firefighting, electrical and plumbing. HVAC is there, heating, ventilation and air conditioning. Then firefighting, which includes fire safety installation like hydrant system, automatic sprinkler system, fire alarm system. This includes all the works related to firefighting. Then electrical means complete building wiring and all the power supply which is there in the building. Then plumbing includes like drainage, sewerage, rainwater piping, whatever drainage system is there, all the plumbing system comes under this plumbing. Okay, so now let us see what are the different stages in a MEP project or any project. Okay, the first thing is like designing. Any project which is there starts from the designing phase. Okay, so for let us consider for HVAC, heat load calculation will be there, pipe designing, pump calculation, machine selection, all this comes in a designing part. Means whatever system we have to design, we will get this in designing. Then here comes the drafting, preparation of HVAC drawings, HVAC, firefighting, electrical, plumbing. After designing, the drafting stage comes. Means in this drawings are prepared for HVAC, for firefighting, electrical and all whatever we have considered in designing, like machine selection, whatever machine we have selected, what are the routing like duct routing, for firefighting the pipe routing, sprinkler design is there, sprinkler pipe design is there. So all this is now put in drawings. We have to show where what we have kept or what we have selected. Then comes the estimation part. Estimation means BOQ preparation. Okay, material cost, labor cost estimation, and then it is put for tendering. Like in estimation, from after preparing drawing we have to take off the quantity. Okay, after taking off the quantity we have to prepare BOQ, and then BOQ pricing will be there, like material cost, labor cost estimation. After estimating all the project cost, it is put for the tendering process. Okay, in a tendering process we select different contractors, whoever provides us better price and good service. We have to select like contractors are selected, and then the project is awarded. After the project is been awarded, then comes the site execution, means installation work at site, and finally commissioning and handover of the site is there. So these are the 4 stages in any project: first designing, then drafting, estimation, site execution. Now let us see what is HVAC, basics of HVAC. So introduction to HVAC. So first we will know what is cooling. Okay, so cooling is a relative process. Difference in final and initial temperature is there. So cooling is a relative process and there is a difference in final and initial temperature. Cooling means the final temperature will always be lower than the initial temperature. Decrease in thermal energy will be there. Temperature, as the temperature reduces, thermal energy will also decrease. It can occur naturally. Okay, cooling is generally referred as a natural process. No other support or aid is there to cool down. Okay, it is a natural process like convection. Through convection, heat transfer is there and the thing is cooled, or any object is cooled down. Example is there: a hot cup of tea dissipates heat to the surrounding environment. After some time, the temperature of tea attains room temperature. See, consider example like a hot cup of tea is there. After some time, it loses temperature, okay, to the surrounding, and after some time, the temperature of tea will be same as the temperature of the surrounding. It cannot fall below surrounding temperature. Tea is cooled down. Okay, like the temperature of the tea will not fall below the surrounding temperature. In cooling, it is mandatory that the final temperature is always less than the initial temperature. This is like the must condition. It will never be there that initial temperature will remain high. As soon cooling is there, final temperature will be less than the initial temperature. Now, final temperature may or may not be as per human comfort. This line is very important. What we expect cooling in general terms, like things will be colder, or when we touch it should be cool. No, it will not be like that always. See, one example is there: cooling iron bar from 700 degrees centigrade to 500 degrees centigrade. For let us take a case. Iron bar is there. We put it in a furnace. Its temperature is raised to like 700 bars. Okay, 700 degrees centigrade. Sorry, 700 degrees centigrade, and it is not like a human comfort temperature. 700 degrees centigrade is very much, and now it is left to cool down. As soon it reaches 500 degrees centigrade, it is still hot, but the process is cooling. The temperature decreased from 700 degrees centigrade to 500 degrees centigrade. It is very clear that this temperature is also not suitable for human being to interact, or like we cannot touch that bar. It is still very hot, but since the temperature is decreased from 700 degrees centigrade to 500, it is termed as cooling. For human comfort, our dry bulb temperature, DBT means dry bulb temperature, ranges from 22 degree to 26 degree. This is our comfort temperature range, 22 degree centigrade to 26 degree centigrade. Okay, so now I think cooling is clear to you all. Now let us see what is heating. Process of adding heat in an internal space if the temperature of particular space is less than the standard temperature by using external means. See, in heating we add the temperature, okay, by any external means. Temperature cannot be added by itself. Any external means is required, like heater, boiler. Okay, whatever we use, any external means must be there to add the temperature. So this is called heating. In heating, there will be always an increase in thermal energy. Now let's see what is refrigeration. Process of removal of heat by producing or maintaining temperature below that of surrounding temperature by external means. Yeah, this is the basic difference between cooling and refrigeration. Cooling will always be done by natural process. Okay, no like convection, no external means is required, always required for cooling. We generally use it in general terms, like this is cool down in there, or like in refrigerator works also we can say like cooling. But more specifically, there is a difference between cooling and refrigeration. In refrigeration, there will always be like external means like compressor, and the temperature will be always below than the surrounding temperature. Okay, surrounding atmosphere temperature. The the temperature which we attain after refrigeration will always be below than the surrounding atmosphere. In this, refrigerant is used to absorb and transport. In refrigeration process, refrigerant is used to absorb and transport heat. Okay, now see, heat will be removed as per refrigeration cycle. Like two cycles are there. Refrigeration cycle, this we will deal in coming videos. Vapor compression refrigeration cycle and vapor absorption refrigeration cycle. Okay, so two cycles are there. Final temperature is always less than the initial temperature and always below human comfort. In case of refrigeration, the final temperature will always be less than the initial temperature and it is always below the human comfort temperature. For example, whatever we you keep it in our refrigerator, it is always refrigerated, and the final temperature, like in freezer, the final temperature is far below than the human comfort. So this is called refrigeration. It is generally used in industrial applications. Generally, refrigeration is used in industrial applications. Okay, see, this is a simple vapor compression refrigeration cycle. Let me give you a idea of this. What is, we will be dealing with the complete vapor compression refrigeration cycle and vapor absorption refrigeration cycle in the coming videos, but now in this video I will be giving a brief detail. So now let us see what happens in vapor compression refrigeration cycle. Let us start from here. See, this is evaporator. Heat is extracted from atmosphere into refrigerant. This is the place where heat is extracted from the atmosphere. Okay, so here heat transfer takes place from the atmosphere. Like see, this is outer environment. Okay, this is like outer. See, heat is taken from here to the refrigerant. Then here the heat carrying substance is refrigerant. It acts as a medium to carry heat. So as soon as heat is extracted to the evaporator, refrigerant becomes here the refrigerant is cool in cooled state. Okay, cold low pressure liquid is refrigerant is there. Okay, as soon as it gains heat, its temperature increases and it is converted into warm vapor or gas, refrigerant. Then it moves from evaporator to compressor. Okay, see, this is compressor. In compressor, it is compressed, the refrigerant is compressed and it converts into hot high pressure gas. After being compressed, the temperature here, it is refrigerant has high temperature, high pressure. Okay, the high temperature, high pressure and high pressure refrigerant goes to the condenser, where heat is removed from refrigerant to atmosphere. Here also the heat transfer takes place and the heat is removed from the refrigerant to the atmosphere. Then again, what happens, the temperature of the refrigerant decreases, but the pressure still remains high. Then the high pressure liquid then the high pressure liquid goes to the expansion valve. Expansion valve is there. Just I am giving a brief summary. In detail I will be dealing the coming videos. In expansion valve, the refrigerant is converted into cold low pressure liquid. Okay, the pressure reduces. Here expansion valve reduces the pressure of the refrigerant and it is again converted into cold low pressure liquid, which is now ready to suck the heat from the outer atmosphere. And this cycle continues, like in this way this cycle continues and heat is absorbed from the surrounding and rejected to the outer atmosphere. Okay, so this is the complete vapor compression refrigeration system, which works in our like air conditioner and all. Okay, now come to ventilation. We have learned what is cooling, what is refrigeration, what is heating. Now coming to the ventilation part. Okay, HVAC comprises of heating, ventilation and air conditioning. So this is ventilation. What is ventilation? Providing fresh air in an internal space in order to maintain sufficient amount of oxygen and to exhaust foul smell given off by people or any other internal components like furniture, carpet, machinery, foods, etc. It is basically maintaining the quality of air. Okay, Ventilation is very necessary for any closed space, like any space is there. Okay, now what this does is like it maintains sufficient of amount of oxygen and replaces the bad air or like foul smell from the environment. Okay, it maintains the indoor air quality. In HVAC, mechanical ventilation fans are there. FHUs are generally used for ventilation purpose. See, this is FHU, fresh air handling unit. In this, fresh air intake provision is there, and the return air, whatever the bad air, foul air comes from the room, is thrown back to the outer atmosphere. All this in detail, we will look upon all the system in the coming videos. For now, just take as a reference. These are the axial fans are there. See this, you can see, you have seen this in many places like warehouses, or this is like ventilation fans are there and warehouses generally used. Okay, these are bigger axial fans are there. So now let's see what is air conditioning. Okay, air conditioning, it is the process of treating air in an internal environment in order to establish and maintain required standards of temperature, relative humidity, cleanliness, motion and distribution of air, and sound level, pressure. So air conditioning is comprises of means complete conditioning of air. Okay, temperature is controlled, whatever our comfort level is, that according to that temperature is controlled. Relative humidity means what first know what is humidity. Humidity is the amount of moisture content in air. Okay, so relative humidity is like amount of moisture contained by total moisture it can contain in 200. Then cleanliness, what amount means like filtration of air, motion and distribution of air, complete distribution of air means airflow pattern, the sound level and pressure. All this is done in air conditioning. Okay, see, according to ASHRAE is a standard society for HVAC. Whatever we design in HVAC is according to the codes and standards of ASHRAE. Mostly ASHRAE, and then ISHRAE is the Indian Society of Heating, Refrigeration and Air Conditioning Engineers. So according to ASHRAE, the human comfort is around 25 degrees centigrade, means ranges from 22 to 26, and relative humidity is 30 to 60%. 60% range is there, and around 50%. So this is the chart for human comfort zone. See, in air conditioning system, temperature control is there. If temperature is too high, like 40 degree, 45 degree, then it is brought down to our comfort level, like 25 degrees centigrade. And if temperature is very low, in at like 15 or 14, then temperatures used to brought up. Okay, so both things occur. Temperature is brought down in case of excess temperature, yeah, in higher temperature, and temperature is brought up when temperature is too low. So this is called conditioning. Okay, now humidify or dehumidify. So these two things occur, humidification and dehumidification. Okay, humidification means adding of moisture content, and dehumidification is removing moisture content. So this all is done as per need. If moisture is less, then humidification will be there. If too much moisture content is there, then dehumidification. Air filtering, cleaning and purification, this is done to maintain the quality of air. Okay, filters are used in all this we will be seeing in the coming videos. Water filters, HEPA filters are there and all. Okay, then cleaning of and purification of air will be there. Air movement and circulation, complete flow pattern of air will be there, so that a human comfort level is achieved. What are the applications of air conditioning? So for human comfort, it is used in residential buildings, offices, hotels, malls. All this is air conditioned these days. You have seen, experienced everywhere. And for like process control, textile machines, CNC, clean rooms are there for medicine preparation, labs, pathological labs, MRI rooms. All this is air conditioned. Okay, air conditioning has a very wide applications in all our day-to-day life. So these are the some of the standard societies or in case of air conditioning. Okay, whatever we design in air conditioning, we have to follow their rules and their codes and standards. So ASHRAE is there. ASHRAE, this is the most followed society. All the design is based upon the codes and standards given by ASHRAE, and in coming series we will be dealing with design and drafting codes based on ASHRAE. Then ISHRAE is there, Indian Society of Heating, Refrigeration and Air Conditioning Engineers. SMACNA, Sheet Metal and Air Conditioning Contractors National Association. All the means duct designing, installation and drafting is based on SMACNA codes and standards. Then ductwork 144, IS Indian Standards, HRI, Air Conditioning, Heating and Refrigeration Institute. Different organizations are there like ASTM, SIPSE, DEWA, Dubai Electricity and Water Authority. These days in UAE they require DEWA approved engineers. DEWA used to conduct one examination. It gives you the certificate. If you pass that exam, okay, then you will be DEWA approved. You will be knowing all the codes and standards of UAE for designing. Then LEED is there for green building concept. LEED is the LEED certification is there. So these are the different standard societies. So one fact is there, like who is father of air conditioning, who discovered it or who invented, Dr. Willis Haviland Carrier. You have already known a brand Carrier in air conditioning field. So this name is given after Mr. Willis Haviland Carrier only, and this is the first company in air conditioning. Now scope for the freshers. Actually, before going to that, let us see what HVAC comprises of. Whatever we have learned in mechanical engineering in BTech, all this will be applied here in designing HVAC. Okay, thermodynamics, applied thermodynamics, heat and mass transfer, refrigeration, air conditioning, CAD, AutoCAD. We will be using AutoCAD for drafting, fluid mechanics. And now the scope. See, due to global warming, there's increased need for of air conditioning for human comfort. Day by day, global warming is increasing. Temperature of Earth is increasing. So air conditioning will be needed everywhere in the coming days. Infrastructure development, too much infrastructure development is there. So every building will be air conditioned in coming days, and because of higher standard of living also we need air conditioning. Okay, so now this is just the intro video of HVAC. In the coming video I will be dealing with the physics involved in air conditioning, like basic terms. What is tonnage of air conditioning, conversion from Fahrenheit to centigrade, centigrade to Fahrenheit, and all the basic physics which we will be using further designing process. Okay, so now thanks for watching this video, and very soon I will be coming with my next video. Okay, bye.